Hello Year 12 further mathematicians. Just going to do a couple of requests from paper 2 further maths internal exam. So paper 2 question 2 was a trig question. You had 3 sine alpha plus 60 subtract 3 cos alpha plus 30 is equal to cosec squared alpha. You're asked to find the exact value of sine alpha. So the only obvious first step is to expand the angle, the addition formula angles. So that would be exactly the same as 3 sine alpha cos 60 plus cos alpha sine 60. Okay, that's given in the formula booklet. Subtract 3 cos alpha cos 30, subtract sine alpha sine 30, and that is equal to cosec squared alpha. And cosec squared alpha is the same as 1 over sec squared. 1 over sine squared alpha. So that's what I would do first. Next thing you would do is you should know the exact values of cos 60, sine 60, cos 30 and sine 30, and then expand the brackets. So I know that cos 60 is the same as a half. So if I expanded that bracket, it'd be 3 over 2 sine alpha. I know that sine 60 is root 3 over 2. So if I expanded that bracket, I would get 3 root 3 over 2 cos alpha. I know that cos 30 is root 3 over 2. So if I expanded the second pair of brackets, or the second bracket, you would get minus 3 root 3 over 2 cos alpha. And I know that sine 30 is a half. So if I expanded that bracket, I would get plus 3 over 2 sine alpha is equal to 1 over sine squared alpha. Simplify. Middle two terms disappear. And you are left with 3 over 2 sine alpha plus 3 over 2 sine alpha, which is the same as 3 sine alpha is equal to 1 over sine squared. You want to make sine the subject. The only logical thing to do is multiply by the denominator. And then if you make sine alpha the subject, you would divide by 3 and cube root. And that would be it. Part B, a little bit trickier. You've got mostly trig ratios with a beta, but then you've got a sine 4 beta at the front. So there was a clue in the question on what to do first. The first thing was to use sine 2 beta plus 2 beta, like so. Sec cubed beta is 1 over cos cubed beta is equal to 8 sine beta plus 2. Keep going. I'm not going to times by that denominator yet. I'm going to expand this first. So if I expanded this, I actually get 2 sine 2 beta cos 2 beta when it's simplified, times 1 over cos cubed beta is equal to 8 sine beta plus 2. Again, I'm going to pause and not times by the denominator yet. You should know some double angle identities for sine and cos. There's only one for sine, and that is just 2 sine beta cos beta. There are 3 options for cos. One is in terms of cos and sine, one is in terms of sine, and one is in terms of cos. Because I would like to find sine beta, I'm going to pick the one which is in terms of sine only and hope that was going to be the correct one. So that's 1 minus 2 sine squared beta over cos cubed beta is equal to 8 sine beta plus 2. Now, maybe tidy up the left-hand side a little bit. I'm not going to expand the brackets. I'm just going to write it as 4 sine beta cos beta brackets 1 minus 2 sine squared beta over cos cubed beta is equal to 8 sine beta plus 2. Now you see there's one thing I can do before multiplying by the denominator, and that is simplify. There's a cos beta on the top and the bottom of the fraction, so the denominator simplifies to cos squared beta and the numerator loses the cos beta, which is good news because we only wanted sine betas. Now I'm going to multiply by the denominator. 4 sine beta 1 minus 2 sine squared beta is equal to cos squared beta times 8 sine beta plus 2. And mostly I've got sine betas, but I've got a cos squared beta that needs to disappear, which isn't going to disappear unless you use the identity, which is 1 subtract sine squared. So 4 sine beta minus 8 sine cubed beta is equal to 1 minus sine squared beta 8 sine beta plus 2. Expand the brackets. 8 sine beta plus 2 minus 8 sine cubed beta minus 2 sine squared beta one thing good happens, which is there's a sine cubed beta on both sides which disappear, but you are left with what looks like a hidden quadratic. If I take everything to the left, I've got 2 sine squared beta subtract 4 sine beta subtract 2 is equal to 0. Divide by 2, sine squared beta subtract 2 sine beta subtract 1 is equal to 0, which is a quadratic. X squared minus 2x minus 1 is equal to 0. This quadratic does not factorize, so I can complete the square, or I can use the quadratic formula to get x equals, have I done this correct? It's probably 1 plus root 2. Have I done that correctly? I'm going to check on the calculator. Sorry, 1 plus or minus root 2. Let's check on the calculator, put the quadratic in. 1 back. Put the quadratic in. 1 minus 2 minus 1. Yeah, looks like that looks right. To give you sine beta is equal to 1 plus root 2 or 1 minus root 2. Now the question said find the value of, which means there can't be two answers unless there's a typo in the question. There is not a typo in the question because if I look at those two values, one of them does not make sense. Sine being equal to 2 point something is impossible. Sine has to be between -1 and 1. So the exact value of sine beta would be 1 minus root 2. It's a lot to do for 7 marks. But that is pretty much it.